So this is the class 10. The subject of this class is the same with the previous one. So here we have indefinite integrals. Okay, we're given this one. We rewrite it as the sum of two integrals. Okay, we can do this. These are the okay. So I mean it doesn't matter. Actually, it is f plus g dx. So this here we need to write dx and dx here. But in general, it's clear. So in general, we don't write dx. And if we have some constant, f, c is constant. This is f, the function f. Dx, this can be written as in this form. We always use this. We used this in the previous class. You know that. Okay. So that's all. You need to know these ones. So here we have what do we do? We use this. Okay, this equality. So we write as the sum of these two integrals. This one's integral is e to the x, okay? And for this one, we substitute this u equals to 1 plus 9 cosinus 8x, okay? And differentiate it and get this one minus 72 sinus 8x dx. So du equals to this, okay? Then this part is equal to du minus du over 72. So for this part we have 4. So we wrote for this part, it's here. Okay, and the rest is 4 over u. Okay, as we said, u is equal to this. So what do we have? We have this integral then, which is equal to this, right? Remember that. So u is equal to this one. Remember, we need to obtain something in terms of x, so we have this. Now what do we have? This was equal to this, right? We had this equality before, and we know e to the x here, and we found this part as in here. Okay, so we have this plus some constant. Now we are given this integral. Now we again rewrite it as the sum of these two integrals. First one we will denote it by a, and the second one we will denote it by b. For the first one we substitute this one, and we get this by differentiating it. Okay, so a is equal to this then, right? So from this, let's rewrite that. So from this one, we get minus du over 50, sorry, 50 is equal to x dx. So here we have x dx, and it's equal to this. And here we have 7, so we get this one and du. And this inside is equal to u, so we have square root of u, okay? And for the second part, b, we substitute this, v equals to 5x, then dv is equal to this, 5 dx, v squared is equal to this. We will use that, that's why I noted here. So b is this, we know this is equal to v squared, so we have 1 minus v squared, and dx is equal to, from that, dv over 5. So we get this, okay, and 1 over square root of 1 minus v squared gives us this arc sinus v, okay. So we have 2 over 5 arc sinus v is equal to 5x, okay. So for b, we found this, okay. Thus, for b, we have this part, And remember, for a, we found that that integral. So here we have. Okay, we rewrite this 1 over square root of u as is in here, u to the 1 minus 1 over 2. So we integrate it and get this one. So here we have minus 7 over 25 times u to the 1 over 2, which is this, plus b. Okay. Now for this, we substitute this equality, the denominator. Okay, when we differentiate and get this. But here inside we see we have 4w plus 3 dw. So if we divide it by 2, we get du over 2 is equal to exactly that numerator. So for this one we have du over 2 for this part, this numerator, and dw is equal to that. Okay, and this was equal to u, so we have this. Now we integrate and get this. Okay, the rest is easy. So here we have we have in the numerator x to the 4dx. Okay, so when we differentiate, if for example if we say u to be equal to this, then if we differentiate it, we will obtain 10x to the 9 dx. But here we don't have something like that. We have x to the 4. So if we say, for example, as in the answer, in the solution, if we say u equals to x to the 5, we will obtain something exactly with something similar to the numerator. So we have this. Now remember that u squared equals to x to the 10. So we have then for x to the 4 dx, here we have du over 5, right? This part, for this, we have du over 5. And for the denominator, we have 1 plus x to the 10, 1 plus u squared. Okay, we use this. So we have this. Then we have exactly this integral, and we know this is equal to arctangent u. So what do we have? We have 1 over 5 arctangent u plus c. But remember, we need to find something in terms of x. So we have here, inside of the arctangent, we have x to the 5. Okay, now we will substitute this equality. We say u to be equal to this, then and differentiate it and get this. So here we have second squared v, e to the we have e to the u for this part, e to the u, and the rest is du. Okay, and how do we integrate it? It's so easy, e to the u plus c, and u is equal to this. In terms of v, we wrote it, we get the result. And for this part, we substitute the denominators as u, so we differentiate it and get this. So in the numerator, we have exactly this part. So we have du over u. The rest is easy. Now, this is homework for you. For this second part, we rewrite it as this form, as in this form. Okay, remember, if we have something f plus g, we can write it in two integrals. So we have this. Now what do? We have two parts, two integrals. So for this first part, we substitute this u equals to x over 2. Du equals to then dx over 2. And then we have this a equals to this part. So we said this is u, so we have sinus u. and the 3dx turns out this part 6du, okay, because dx is equal to 2du. And what about the boundaries? If we plug pi over 3 for x here, we get pi over 6. And if we plug x equals to 0, we get u equals to 0. So we have this integral now. And for b, we substitute this pi minus x and get here minus 5 cosinus v dv. Okay? This minus comes from this equality. Okay? And the boundaries, similarly, if we plug, here we have pi over 2 for x. If we plug here pi over 2, we get it is pi over, if we plug pi over, sorry, I made a mistake there, it's pi over 3, right? Here we have pi over 3, it should be pi over 3. So if we plug pi over 3, we get v equals to 2 pi over 3. And if we plug 0, we get pi, okay? This part was pi over 2, which is not correct. It should be pi over 3. So here we have b and a. Now what do? We compute these integrals. Now for this one, we know it's equals to minus 6 cosinus u from this to this 0. Plus, here we have plus, minus, minus, we have plus. So for this part, we have 5 sinus v from this point to pi, and we can easily get this. Okay, we just plug u equals to 0, then this, and v equals to pi, then this. Now, for this, we substitute this tangent, okay? So if we differentiate it, we get this. What do we have? We have sinus tangent theta, which is sinus u here, okay? And we can rewrite this 1 over cosinus squared as secant squared, right? Then what do we have? Secant squared d theta is equal to du. Then we have sinus u du, okay? We change the boundaries. If we plug theta equals to pi over 4, sorry, here, theta equals to pi over 4, then we obtain 1, and if it's equal to 5 pi over 4, we get minus 1. So we have this minus cosinus u from 1 to minus 1. We plug them and subtract. So for this part, it should be first with t, sorry. It's t, suppose it's t. So we plug, we rewrite this denominator as in this form, right? If you compute this, you'll get x squared plus 4x plus 4 plus 1. So you have exactly this. Now we substitute x plus 2 equals to u and differentiate and get the u equals to dx. So for this part, we have exactly this. So we said x plus 2 equals to u. So we have u squared plus 1, right, in the denominator. And what about the boundaries? If x equals to minus 3 here, we have minus 1 for u. And if it's equal to minus 1 here, we have 1, okay? Then what do we have? We have this arctangent u from minus 1 to 1, okay? We plug them and subtract and get this minus pi. Okay, now for this one, we will again apply integration by parts. So we say u to be equal to x and dv equals to tangent squared dx. Now du equals to dx then, and v equals to, if we integrate it, we get tangent x minus x, right? We use this identity secant squared minus tangent squared equals to 1, okay? So we have this tangent x minus x as v, as the variable v. Now we rewrite this, sorry, we don't rewrite, we apply integration by parts and get x, so here u times v here, minus v is this tangent x minus x, and what about du? It's here dx, okay? So here we have this integrals. We rewrote this integral as in this form. So this is basically x squared over 2. And what about tangent? It's minus ln of the absolute value of cosine x. And here we have also minus, so we get plus. Okay? And this is the result. These are homeworks for you. Now, this is a little bit longer. So we will apply integration by parts 2 times. Okay? Now, first we say u equals to cosinus 2 theta and dv equals to the rest of the integrand, okay, e to the minus theta d theta. And du equals to this, we differentiate this one and integrate this one and get v equals to minus e to the minus theta. Now apply the integration by parts, we just apply this and get this one. So we will say this part A, we will call it A, and we will apply integration by parts for this part, for this integral A, okay? What do we say? We say let S to be this sinus 2 theta and dt to be equal to e to the minus theta d theta, okay? So we differentiate it and get this equality and integrate it to obtain t and get minus e to the minus theta. Now, using integration by parts, we write a as in this form. So it will be s times t here minus the integral of s dt. So here we have. Now, what do we have? We have this. Now, remember, we're given this integral as in here. And from A, we obtained something similar to that. So let's plug this one into here, okay? So we had before this, we wrote that, which was equal to this one, minus cosinus 2 theta e to the theta is in here, minus 2a here. And we computed a, right? We evaluated and get this equality, okay? First we had this equalities, okay, we wrote here, and we have the same with this, and for this part, which is a, it was equal to this, so we wrote it here, okay? Now, what do we have then? So we have this one, the last equality, if you look at, we have this minus for this integral, and here we have that integral, the same one. So we write this on the left, and we get 5 times of that, which is equal to the rest, which is this. If we divide by 5, we obtain what we desired, okay? We wanted to compute that, right? And finally, we have this. Okay, this is also homework. For this one, we substitute u equals to x squared plus 1, then du equals to 2x dvx, and dv equals to e to the minus x dx. Then v is equal to this minus e to the x. By integration by parts, we get this, okay, u times, here u, v, which is minus e to the minus x, from 0 to 1. We had these boundaries before, minus v du, which is, here we have v, du is this 2x dx, okay, from 0 to 1. And the rest is easy, you know this. Now here we have this integral, we have e to the minus xx, right? So it's clear that we need to apply integration by parts for that. So we say s to be equal to x and dt to be equal to e to the minus x dx, and differentiate and integrate to get the values that we will use after. So a is equal to then s times t minus the integral of t ds. Okay, ds is dx, so here we have. Now the rest is easy, we just plug the variables and get the result. Then a is equal to this, 1 minus 2 e to the minus 1. So this is, which is we wanted to find, is equal to this one. And here, instead of a, we write this result and get this. Now we will again use the integration by parts. We say u to be equal to x e to the 2x and dv equals to this. Differentiate and integrate and get these values. V is equal to that and du is equal to this. Now what do we have? We're given this, so we write it in using the integration by parts and get u times v minus the integral of v du. So we have this. Now call this part a, and we will substitute s equals to 2x plus 1. If we differentiate it, we get this. Now we note that 2x equals to s minus 1. Just using this equality, we obtain this. Okay, it's easy. And e to the 2x plus 2x e to the 2x is equal to, here in the parentheses of e to the 2x, you can rewrite this as in this form. And 2x is equal to s minus 1, so this is equal to e to the s minus 1, and this was equal to s, so we have s times e to the s minus 1. Now then a is equal to this, a was this integral, then a is equal to this by using this, 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 and this, we obtain this integral. Now then we have 1 over 4 and this integral. Now this integral is exactly equal to this, e to the s minus 1 plus some constant. Then s minus 1 was equal to 2x, so we have this, okay? Now then, this was the integral we wanted to compute. So this is equal to this part, as in here, and plus a. And a was equal to this, we computed before. So we have exactly this. Okay, we're given this integral. So question says that first make a substitution, then use integration by parts. So let's say s to be equal to minus t squared, then its differentiation is this. And then we have e to the s, here, e to the s, t squared times t, which gives us t to the 3 dt. Now we know t squared is minus s, right, as in here, and dt is equal to, from that, minus ds over 2. So we have this integral. Now for this integral, we will apply integration by parts. We say u equals to s and dv equals to the rest, e to the s ds. And as you know, you should know by so far, so we have this for a, the result. Now we're given this, we know it's equal to that, and that equals to this part. So we have 1 over 2 times this. Okay. So we need to write it in terms of t, right? Don't forget that. So here we have. Okay, so this is, again, we will use substitution first. We say s to be cosinus t, then its differentiation is this. So we have then this e to the cosinus t, 2 cosinus t sinus t dt, right? This comes from that, this identity, sinus 2t equals to 2 sinus t cosinus t, okay? Here we have this. Instead of that, we wrote that. So we used it before. Okay. Now what do we have? Cosinus t is equal to s. So we have e to the s. And for this part, we have, we have, by using this equality, we have 2s minus ds. Okay. So this is equal to, this is equal to 2s, and this is equal to minus ds. Okay. Now we have this then. Oh, remember, we need to change the variables. So when t is equal to 0, cosinus 0 is 1, so we have 1 there. And when t is equal to pi, cosinus pi is minus 1, so we have this. Now we have this integral. Okay, for this one, we apply integration by parts, which is exactly the same with the previous question. So we have easily this one. Okay, now then this given integral turns out this one. Okay, as in here, and this is equal to, here we computed before this, from 1 to minus 1. The rest is easy. Okay, this is the last question, and this is homework for you. Now what do? We substitute t equals to square root of w. Then if we differentiate it, we get dt equals to 1 over 2 square root of w dw. So this gives, then sinus square root of w turns out this 2, so it comes from this equality, 2t sinus t dt. Okay. Now we will apply integration by parts. So we say u equals to 2t and dv equals to this sinus t dt. Differentiate it and integrate, obtain du and v. Then by integration by parts, we get u times v, okay, minus the integral of v du. So here we have. Now what do we have? We have the same for the first part of the summation, and for the second part we have 2 sinus t. Now we plug this equality and obtain this result. Okay, so as I said before, this is homework for you. Okay, this was the last question. I hope you understand. If you have any question, you can attend the office hour on Friday. Okay, so good luck.